This is a continuation, correct?
Correct. We are continuing our lesson from yesterday. So let's begin with some review. What is the derivative of velocity called?
What? Derivative of velocity?
You guys are rusty. Acceleration.
I knew that.
Somebody said it. You said it. I was waiting for everybody else. All right. Now let's talk about what it means to have a positive acceleration. Positive acceleration. That's your acceleration is the slope of your velocity, right? So if you have a positive acceleration, that means your velocity has a positive slope, which means your velocity is increasing. Now there's two ways that you can think of that. If you already have a positive velocity and it's becoming more positive, or if you have a negative velocity and it's becoming more negative. Okay? Either one of those. What did I say? Less negative, you're right. Thank you. So now let's think of this as a dot moving along an axis, right? Like what we talked about yesterday. So if I have a positive velocity, that means I'm moving to the right. And if I'm increasing my speed to the right, then I'm accelerating to the right, right? However, you can also have a positive acceleration and be slowing down, because if you are, let's say you're moving to the left, the acceleration could, so then my velocity is negative, right? So if I'm slowing down as I go to the left, that's considered a positive acceleration, because now I'm slowing down and becoming less negative. All right, that's confusing. We'll look at a few examples in a minute, but for now, the flip side of that is the negative acceleration. That just means your velocity is decreasing. The two ways you could think about that is becoming less positive or more negative. All right, so something that we talked about a little while ago is this little table here. And the way I exemplified this to you was with a man running, or a woman, and then somebody pulling on that person with a rope. Remember that? Yeah. The rope is the acceleration and the person running is the velocity. So if I'm running to the right, what's my velocity? Positive. And what if Heather lassos me with a rope and starts pulling me to the right? What's the acceleration? Positive. They're both positive. What's going to happen to my speed if that happens?
Increase.
It's going to increase. So whenever your velocity and acceleration are both positive, it increases the speed. But let's say I'm running to the right. What's my velocity? But now Heather's behind me with a rope pulling me. What happens to my speed? Decreasing, right? So whenever if you have positive velocity and negative acceleration, that decreases your speed. What do you guys think is going to happen down here with a negative velocity and a positive acceleration?
Kitty corners.
Yes, that's true. It's decreasing again. So in this case, I'm running left, but I'm being pulled to the right. And whenever I'm running to the left, negative velocity, but being pulled to the left, negative acceleration. What's my speed doing? So as Jill had said, the diagonals are the same, right? So now here's a much easier way to just remember this. Anytime your velocity and acceleration have the same sign, you're increasing. If they have opposites, you're decreasing. Okay? All right.
It's like if you added a positive and a negative, it's always going to be negative.
Okay, that's a cool way of thinking about it. It's a good way to remember it. All right, let's move along. We're going to do everything that we did yesterday, but this time we're doing it from a graph perspective. Joyfully. All right, we're going to do it from a graph perspective. You looked like you were frustrated, or were you just stretching? Oh, as soon as I pulled up the slide, you went. Oh man.
I thought this was the whole website.
No, yeah, not all of it. Yes.
You have more of the notes.
I do. I can't get them right now to print it for you, but I'll get some for you in a minute. For now, you can just kind of watch. All right. So yesterday we did all this stuff, but we did it with an equation. Today we're doing it with graphs. So displacement. First of all, let's review what that means. Displacement means what?
displacement.
Start here.
When it like flies over here, it comes out
Something minus something.
like five people talking.
I heard good things. Here's a nice down to earth definition. Yes.
Isn't it like whatever S of whatever is equal to your starting thing minus?
Is it the area under the curve?
You guys are all saying good things. Here's what I want to hear though. It's how far you are away from when you started. Sorry, I didn't get a chance to hear you. Now, what Tao and Jill were kind of hinting at, that's the how. How do you get it? Okay. The way you get it is you integrate the what? No.
The area.
You integrate your velocity, right? Now I want to find out what's the displacement at t equals 9. So what do I write? That's right. We're going from 0 to 9. So I just need, this is my displacement. And when I'm done, whatever number I get, that number tells me how far away I am from my starting point. Okay? So let's go ahead and do that. Integral here. Yesterday we did this on our calculators, but today we're going to use geometry and just figure it out. Okay?
That's why I did the homework.
So, good. That's nice. Then today will be just an easy thing for you. All right, so from here to here, the area is 9/2. From here to here, it's 6. This little triangle right here is 3/2. And this little triangle right here
Wait a minute.
is negative 27/2. Okay? Notice it's negative too because it's under the curve, right? All right, so if I'm going all the way up to 9, then I got to add all those up. So 9/2. I'm going to put my like terms together here, the ones with the common denominators. Makes it easier for me. All right, so I've got 12 take away 27. What's that? 15? So I've got negative 15 over 2 plus 6. I guess we could just go decimals here. Okay, what does that number mean?
How far it is from? Yeah.
Okay. Okay, good. You answered the second question. There you go. So let's take a look. We're on the y-axis, so it's not to the left, it's below it, right? Now so that's wherever I started from after I have had this velocity, after I've been moving around according to that function, after 9 seconds, now I'm 1.5 units below where I was originally. Okay? That's called displacement. All right, let's go ahead and take a look at the next question. Find S of 9. Now that's my position. Now I gave you guys a formula for position yesterday. It's S of x is equal to your starting position plus your displacement. And I think some of you guys were kind of suggesting that formula earlier when I was asking what displacement was. So we want S of 9. Now we know what S of 0 is because the directions tell us. What is S of 0?
4.
It's 4. And we know what our displacement is because we figured that out in part 1. So what's that? And therefore, where is my position? 2.5. And that makes sense, right? Because that's 1.5 spaces below 4, the starting spot, like we thought it would be. Okay? So there it is. That's our position. So we found displacement, we found position. What's next? Can I erase? Well,
I understand.
next time.
I understand.
Oh, yeah.
Good.
I have to pay attention. No, to see me to participate.
Good. Can I erase? Okay, let's do the next one.
Find the distance traveled at
Thank you. Now we want distance.
Yeah.
What did we learn about how to find distance yesterday?
Absolute value.
That's right. Okay, bonus point time. What's another word for the absolute value of velocity? You gotta raise your hand. Yeah? Huh? No? Yes. So when you integrate this,
Wait a minute.
when you integrate speed, you get distance. When you integrate velocity, you get displacement. I didn't state it like that yesterday, but
You do not.
that's why. Well, actually, that makes sense because that's an old topic, actually. Hard to remember, but it's an old topic. We did talk about it.
That makes sense. Oh my God, I feel so dumb.
All right. Now, let's do this. Now, when we're integrating an absolute value, that means the velocity is always going to be what now? Positive. So this piece down here gets flipped up here. We're not looking down here anymore. So now it's 9/2 plus 6 plus 3/2 plus 27/2. So no minus this time. It's all plus. Let's see what that is. 9 plus 3 is 12 plus 27. 39/2, which is 18.5. 18.5 plus 6. Man. Is it 19.5?
It should be 19.
Okay, that sounds right. You're right. 25.5. So just add them all up, basically, right? All right. So that's distance. So notice the distance was 25.5, but the displacement was only -1.5. So it must have went really far up at some point and came back to where it was. If it traveled that far and ended up only one space away from where it was, right? All right. I guess it could have went down too. I don't know. I have to think about it. I don't want to answer 4 yet. It takes a little bit of thought, but some people in my 5th period were able just to figure it out just by looking at it. But hold off on that one for now. I want to come back to that. When is the acceleration positive? Okay, so acceleration is the what? Velocity? The slope. When is the slope of this graph positive? There you go. So that's the answer. That's where the acceleration is positive, from 0 to 3. All right, so therefore, where is the acceleration negative? All the way to 9. 5 to 9. Okay. All right, next question. When is the object speeding up? Now, that's a little bit of an involved question here. So I'm going to show my work up here. In order for this thing to be speeding up, one of two things has to be happening. You either have to have a positive velocity and a positive acceleration, or you can have a negative velocity and a negative acceleration. Remember how we said that whenever their signs match, it's speeding up, right? All right, so let's start with acceleration since we just highlighted those. So here's this pink region here is a positive acceleration. Is there any part of that where the velocity is also positive? The whole thing, right?
Yes.
From here to here, they're both positive. So that whole spot is a place where it is speeding up. Okay, now let's take a look over here. This is where my acceleration is negative. Is any part of that got a negative velocity? 6 to 9, right? Not this piece, right? Just from here down. Because the acceleration is negative the whole way. But the velocity is positive until it gets here, and then the velocity is negative. So when they're both negative is from 6 to 9.
So they're both speeding up?
Those are intervals where the object is speeding up. Okay? So the next question is going to be, where is it slowing down? So in order for an object to be slowing down, that means they have to have opposite signs. Okay. I guess I could just delete it. That works. Does that work? No, that's not working for me. I'm having trouble because my board's not calibrated, so I have to do it over here. I can't reach my erase button. All right. So, slowing down. There's 2 ways that could occur. Either my velocity is negative and my acceleration is positive, or my velocity is positive and my acceleration is negative. They have to be opposite. So let's see. Now over here, this is where my acceleration was positive. Is any part of that got a negative velocity on it? No. So this doesn't exist for us then. We don't have anywhere on this graph where the velocity is negative and the acceleration is positive. Over here, I have a negative acceleration. Is any part of that got a positive velocity? From what to what? Jacob, you always sound offended. All right, 5 to 6 then is where it's slowing down. All right. Okay, before I set you loose, I want to do number 4 now. Let's go back to number 4. All right. Now number 4, I'm asking you, when is the distance from the origin the greatest? Okay. So I'm trying to find when S of t, the position, is greatest. Yeah. Okay, just put it over there, yeah. So I want to know when this number is greatest or least, right? Because whenever the position is greatest or least, that's when it's going to be farthest away from the origin, correct? So how do you find the maximum of a function? That's actually part of it. How about candidates test? Candidates test. All right. So the candidates test tells me that if I have a maximum of this function, then it's going to happen in one of 2 different spots. What 2 different spots could it happen at? At the endpoints, which are what and what?
0 and 9.
Or it could happen at the what? Starts with a C. Critical values. Now, what are critical values? When the derivative equals 0, right? Okay, so what is the derivative of S of t?
1. Oh, there's a.
No, they're not. You can have it. No, that's not the derivative. That's the position at 0. I think. Oh, no, never mind. No. I don't know what 1 means. Why would you think it's 1? No, S of t is a function. It's a position function. All right, so let me help you guys out here. S of t is this. The position at any given time is equal to your starting position plus your displacement from 0 to t. Oops, no parentheses there. So, if I want to find the derivative of this, what happens to S of 0? Goes away because it's just a constant. And what's the derivative of this? So the derivative of my position is its velocity. Is that ringing a bell? You guys remember from chapter 5, the derivative of your position function is your velocity function? And the derivative of velocity function is your acceleration function? We should have reviewed this again. All right, well, there it is. So that's an old concept. The derivative of your position function is the velocity. So if I'm trying to find out my mins and maxes, let's return to this. You use the endpoints and the place where the derivative equals 0. Now the derivative of S of t is what? V of t. And I want to know where that equals 0. Where does V of t equal 0? 0 and 6. In other words, where it touches the x-axis. Your critical values are where it touches the x-axis. We'll have to look at more of these types of questions I see, but you guys will get to see it today. But this is actually very important because, you know, if I was on the AP exam, I would like you guys to get to a point where you wouldn't have to think so hard about that. You would just know endpoints, x-intercepts, boom, you've got your test points, right? Because that's where the critical values and endpoints are. Anyway, let's go ahead and figure these things out a little bit. Now, I already found S. We already know S of 0. What's S of 0? Okay, S of 0 is 4. And we already figured out 9 earlier as well. What is S of 9? Yes, 2.5 is correct. And we haven't figured out S of 6 yet. So let's figure out S of 6. So S of 6 is S of 0 plus the displacement from 0 to 6. All right, what is S of 0? 4. And let's figure out what this is. That's just the area of your function from 0 to 6, right? So that's 9/2 plus 6 plus 3/2. 12 is right. All right, which of these points? Oh, you're right. You're right. Thank you. So what is it? 16. All right, so you should get a point for that. I do.
Oh my.
So, what was our question? What was I trying to find? When it's farthest away from the origin. So which one of those numbers is farthest away from the origin? 16. So the answer for this is t equals 6.
How is it not 9? Why is it 6?
So why is it not 9? Now so in my last class, somebody knew the answer before I threw this whole nonsense of Canada's test at them. You need to see that because on an FRQ, that's how you show your work. But they used some, I'll call it common sense, although it's not common sense. Which way are we moving here? That's all positive velocity, so I'm moving which way? Up. And then what starts to happen? I start to come back down. And probably when I'm right about here, when this area equals this area, I'm back to where I started. And it's going to be a little bit more. So then it ends up being a little bit below it after that. So do you guys see why I'm moving up, 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 and then I start coming back down? Where does it reach its highest point away from the origin? Right there, right before it starts turning around and coming back to the origin. Yeah, a little bit, yeah. There you go. Yes, yes, very good. All right, so there's that. But since it was asking about distance, you also want to look at mins if there are any, because if it was farthest away from the origin was a negative number, then we want to look at that too. All right, anyway, so here you guys go, see what you guys can do. If you didn't get to those ones, you'll get it. All right, so let's go ahead and do the student practice here now. Number 1, my first question is going to be, how do you do it? And then after that, I'm going to ask what you got for your answer from a different person, okay? So, Eric, how do you do number 1? You find the area. Okay, good. Good. Now, I'm going to, in calculus, we would write it like this, right? Now, I'm going to ask you, what did you get for the displacement? That is correct. You add up all the little area chunks. You should end up with a negative 6.5. All right. Jocelyn, how do you do number 2? Oh, you. Mm-hmm. So S of 10 is equal to what? Good. From 0 to 10, right? So S of 10 is equal to the starting place plus the displacement. And so I shall now ask Jacob, what is the answer to that? Okay, let's see why. S of 0 is negative 8. And we just had somebody tell us earlier that this was negative 6.5. So when you combine those, you get negative 14.5. So that's where the object is located after 10 seconds. And we're on a y-axis, so that would be down 14.5. All right, so Anthony, how do we do number 3? So we take the absolute value of the velocity function, right? So it's the same thing as number 1, but this time it's an absolute value. So we're looking for the area of this shape. It's not drawn right, but something like that. Okay. So, ooh, wrong class. Let's ask Tao, what did you get for the number 4 then, or number 3? I mean.
Oh, that's right.
35 what? Okay. So 17.5. So if you add together all these triangles, 17.5. All right, moving along. Wendy, what did you get for? You got the hard one, Wendy. Number 4. T equals 1. Let's find out. So candidates test. When you do the candidates test, Jesus, what do we have to use with the candidates test? But what do you use? Huh? Yeah, critical values. Good. I'll give it to you. That's right. Now, my next question is going to go to Michael. How can you tell just by looking at your graph what your critical values are? That's good, but that's not the critical values. I'm going to use that one too, but that's not the critical value. Jocelyn Solano, how can you tell what your critical values are? Okay, that's not the critical values, but I'm going to include those because that's what you and Michael said. So 0 and 10, but how do you find the critical values? Let's try another person here. Jackie, how do you find the critical values? That's right, but on the graph, Kwaku, how can you tell where the derivative is 0? Okay, it's the x-intercepts, here and here. Is it 7?
Yeah.
Okay, so she's changed her answer to t equals 7. So let's see. Now, what is the object's position at 0, Kirsten? T equals 0. -8. Yeah. Now we got to find the position at 1. So how do I do that? Well, the position at any given point is the starting point, which we already know is -8, right? So let's write that. Plus the integral from 0 to whatever number you want. And basically that's just the area. So if you want to find out where you're located at 1, we're going to have -8 plus that area. So what's that area? 1. So what's 1 plus -8? -7. Now 7, it's going to be the starting point plus the area once again. So from here all the way up to here. So what was this area? 12? -12, right? And this is 1? So we have -8 plus 1 minus 12, which is -19. Okay. And then finally we have 10. So S of 10, once again, it's -8 plus the area. So to get the 10, I just add this much, which is 9/2. So that would be 1 minus 12 plus 9/2. And what did you get? $14.5, somebody said?
No, wait. So you got it? Okay, just combine though. That's -15. -15. What? No. Wait. Wait, -14.5. Yes.
That's the same answer as the last one? Yeah, okay.
Yeah.
All right.
Wow.
So when is it farthest from the origin? At t equals 7. Right there. It's at 19 at t equals 7. All right, that one was kind of hard. Joanna's gone again. Let's see if we can find Jonathan. Jonathan, when is the acceleration positive? 3 to 10. Any questions? Next, Heather, when is the acceleration negative? Good. Next, Jillian, coming at you, girl. All right. When is this object speeding up? There we have a negative acceleration, and here we have a positive acceleration. So where is the object speeding up? 1 to 3. Good. You got it. On these two intervals, the acceleration and velocity agree in their signs. Negative velocity, negative acceleration. Positive velocity, positive acceleration. So, and when is it slowing down? I'm out of cards, so that would be the other one though, right? So like here, the velocity is positive, but the negative, or the acceleration is negative, so it's slowing down there. And it's also slowing down here where the velocity is negative, but the acceleration is positive. All right, fun stuff. I want to do one more tortuous thing with you. So go ahead and write down this one. I think on your guys' notes, this is a T or an X, so if you guys could change that to a T for me. All right, so we're going back to equations here, but we're going to ask that same question that we asked earlier, when is it farthest away again, but this time we're going to answer it with an equation instead. All right. So let's say that let S of t represent the position. Let S of t represent the position, okay? Now, as you guys know, we've already said in the last slide that S prime of t, what's the derivative of your position function? It's the velocity. So I'm just kind of preparing your minds for what's coming up here. All right, a particle is moving according to this function here. At t equals 0, the particle is at position 1. When on the interval from 0 to 3 is the particle farthest from the origin? When is it farthest from the origin? So I'm looking for a max, right? So we're going to do candidates test again, right? So I need to do my endpoints. What are my endpoints? Zero and 3. And I shouldn't call this x, I should call this t. So at these time values, I'm going to have these s values, which are x values. All right, so 0 is one endpoint, and 3 is the other. So other than endpoints, what else do we want? We want critical values. And how do you find critical values? You find where the derivative equals 0. So what we're going to do is we're going to graph this function, and we're going to find where it equals 0 on our calculator. Instead of setting it equals 0 and solving it by hand, when you have an ugly function, we use our calculators. So go ahead and start by graphing that function. All right, here we go. So the function is, mine's already graphed. When you're all done, it should look like this, so I'll wait for you guys a little bit. That's a good question. I'll answer that in just a second. Are we all ready? Yeah. So I want to zoom in on this region here. So And I really only care about the region from 0 to 3, don't I? So I don't want to start at 0 and stop at 3, because if there's something happens right at the edge, I'm not going to see it very well on my calculator. So I'm going to go a little bit past both of those. So go to Window, and for your X min, let's put negative 0.5. And for your X max, let's put 3.5. And then look at your graph. That way we can look at the parts that we really only care about. Did you put a negative or a minus? Huh. That's weird. I'd have to look at it to see what's going on. Not sure. I'd say just try again. But you just push Window, right? And then at X min, you put negative 0.5, and then at max, you're going to put 3.5. Did you get them backwards and put the negative at the max? No? Huh. That's weird. I'd have to look at it. I'm not sure why it would be doing that. So what am I looking at a graph up here, you guys? Kind of. But like in the context of the problem. This is the what graph? Velocity. I want to know where it equals 0. How can you tell by looking at this graph where the velocity equals 0? Where it touches the x-axis. So and we're going to do this a lot actually, hopefully. I'll show you guys how you can use the calculator to find where it equals 0. So push second, Calc, you see where it says 0? Push 2. Second, Calc, and then where it says, it's right here, where it says 0, that's number 2, you're going to push 2. You good? Okay, now it says left bound. What I'm going to do is I'm going to tell my calculator a certain region to look for a 0. I'm going to pick a point to the left and a point to the right and say, please look for a 0 in that region. So let's say I wanted to find this 0 right here, right? So I'm going to scroll over, and I'm going to pick a point to the left of that 0. So right when I'm to the left, I'm going to push Enter. And now it asks for a right bound. So now I'm going to scroll a little bit above that 0 to the right of it and push Enter again. So now I've told my calculator, I want you to look in this area here for a 0. See those little arrows? So it's going to look for a 0 in that region. So you just push Enter one more time, and it will tell you the 0. There it is. So let's go ahead and write that down. That's 2.507. Now this is a what value? Critical value, and these are what? Just labeling my work so that you guys will know what you're looking at when you look back at your notes later. All right, now I need to figure out what S of 0 is. I need to figure out what S of 2.507 is, and I need to figure out what S of 3 is. Now we already know what S of 0 is. What's S of 0? They tell us it's 1. It starts off at a position of 1. We don't know these other two, though, right? All right, so you guys ready? To find these, how do I find this position? It's going to equal what? 0 to, there you go. And then this one's going to equal what? Same thing, just the top numbers of 3, right? Okay. Now, before we go, I'm going to store this number on my calculator. Ready? Here we go. I want you guys to push Enter. It goes away for a second, but don't worry. And then push Store, and then X. Enter. So it stored that number. Now we're going to type in this expression. Now we already know what S of 0 is. What's S of 0? So let's just go ahead. That's what we're going to type into our calculator. So here we go. I'm going to do 1 plus the integral from 0 to here of v, and that's going to give me my answer. So 1 plus math 9, and I'm going to put my function in there, my v function, which is where? That's right, it's under vars And we're going from 0 to what? To x, right? I'm not going to type 2.507. I'm going to put x because my calculator has that value stored under x. And then enter. Looks like we didn't get to finish. I will finish it. You guys can watch the video if you want to. But this will turn out to be the one that's furthest away from the origin. I'll see you guys later. I'm going to repeat that process with this one. So I don't have to retype this whole thing. What I'm going to do is I'm going to push second entry. It brings the whole thing back again. And I just need to come up here and replace my last endpoint x with the 3, because that's all that changes. And I don't have to type it all again. So
Go home anyway. You would never have them.
this is the highest values, or the value that's furthest away from my origin, and so that would be the answer.